I say this bracket here, that means it's a stress unit. Normally is quoted in MPa. Okay, in MPa. MPa means is equal to Newton millimeter square. Okay, Newton millimeter square. Or yeah, this M is mega. Mega is 10 to the 6, right? Okay, mega is 10 to the 6. Pascal is Newton per meter square, right? Right? Okay, so, but this meter square is equal to 10 to the 6 millimeter square, right? So that is why megapascal, which is 10 to the 6 multiplied by Newton per meter square, which is the same as Newton per 10 to the 6 millimeter square, and then you 10 to the 6, 10 to the cancel out, and that's what you have is Newton per millimeter square. Okay, all right. So remember, the unit of the stress is always in MPa, and which is Newton per millimeter square. Okay, because for example, our concrete grade is either 30 MPa or 40 MPa and so forth. Now, your stress. Okay, starting with your stress, this is now your stress, right? Okay, let's say F1 is equal to Pi over A, right? And then, let me put the negative Pi over A and positive Pi multiplied by E divided by S1 and negative M cell weight divided by S1, right? This is a transfer, right? A transfer, right? Correct? So, Chica, you see here you do negative 1325 kilonewton, right? So I give you kilonewton. Here area is, you do 1.5 times 10 to the 5 millimeter square, correct? Right? And then here plus your Pi is 1325 kilonewton, and then here you use 150 millimeter, and then here you have 1.8 times 10 to the 6 millimeter cube, right? Correct? And then you have negative 70, 75, 75 point,
77.
huh? 77 point, 77.76, right?
Yeah.
77.76 kilonewton meter, right? And then 1.8 times 10 to the 6 millimeter cube, right? Correct? So what you do is you just use this number, right, to calculate. Then your units are not correct. You see this, the first one, the units is kilonewton millimeter square. If you just use this one, correct? Let's say if you just use this one, then the units is kilonewton millimeter square, right? And then the same thing, if you just use this one, you also have kilonewton millimeter square, right? Because your millimeter and this one cancel out, correct? So your units is kilonewton millimeter square. But this one, if you use this, just to do this, what you have is your unit is kilonewton meter millimeter cube. Because meter and millimeter cannot cancel out. You understand? So you cannot just use this one and add. Understand? Okay, now, so what you do is, this millimeter square, millimeter cube, we don't change the units, okay? We don't change the unit, okay? What I want to show you is this one here. 1325 times 10 to the 3 kilonewton. I change to 10 to the 3 Newton, right? Okay. And then over here, what I'll do is, actually I want to change to 180 multiplied by 10 to the 3. 1.8 times 10 to the 5 is 180 times 10 to the 3, right? Okay, alright. In the area, you try to express it times 10 to the 3. Don't do. The reason is, then this one I can cancel. Understand or not? Okay. So this one now is millimeter square. Then this one becomes negative 1325 divided by 180 MPa. Correct? You can follow now? Okay, okay. This is the first term. Then the second term is okay, let's look at the third term first. Third term here, kilonewton meter, I change it to 10 to the 6 Newton millimeter. Understand? Why do I do that? Because this one here, kilonewton meter, I change to 10 to the 6 Newton millimeter. So this one is originally kilonewton meter, right? Kilo, 10 to the 3 meter, 10 to the 3 millimeter. Okay? Understand? So why do I do that? Because I cancel out. Understand? Okay, so then this one, what you're left with is negative 77.76 divided by 1.8. Okay, cannot. Okay. 18, right? 18 and times to the 6. So this is 18. Then the units is millimeter Newton per millimeter square, which is MPa. Understand? Okay, so because when you calculate your moment, your natural unit is kilonewton meter, right? So kilonewton meter, you convert it to 10 to the 6 Newton millimeter. Understand? Then 10 to the 6 and 10 to the 6 cancel out. Then what you left is 77.76 divided by 18. Over here, you also do this. It's okay. No, here is 150 millimeter, right? .15 meter. Understand? Why? Then here you can see that this is 1325 times 0.15 kilonewton meter divided by 18 times 10 to the 6 millimeter cube. Because this is a pre-stressing moment. Okay? So pre-stressing moment, because then again my kilonewton meter I convert it to 10 to the 6 Newton millimeter. I say 10 to the 6 cancel out. Okay? Then this one becomes 1325 times 0.15 divided by 18, correct? Right? MPa. Then minus 7.76 divided by 18 MPa. Then my units are the same. Okay? Because different units cannot add together one. See what I'm saying? You cannot. Let's just say that you cannot add 36 kg plus 10 G. You cannot just add like that right now. Either all of you is in kg or in G. You understand what I'm saying? Let's say my length. My L1 is equal to 3 meter. My L2 is equal to 2 millimeter. My L3 is equal to 3 kilometer. I cannot just add and say 3 to 3. Right? If you add 3 to 3, let's say 3 to 3, this is 8, right? But what's the units? Should I take kilometer, millimeter, or meter? You see what I'm saying? So when you add these things together, in engineering, when you add together, you make sure that these things have the same units. Otherwise, you cannot add together. You understand what I'm saying? Alright? That is why what you are doing is, you are just adding the number. You see at the, over here, okay, you change it already. Oh, because over here, you are just adding the number without making sure that the units are correct. You understand what I'm saying? Okay? So that is why it's important to carry the units. Always remember that the area most likely will be in millimeters square. Okay? Because the section that I give you is 300 by 600. So very naturally you use 300 multiplied by 600. So that unit is millimeter square. Same thing, the section modulus also millimeter cube. So never mind, we keep this millimeter square, millimeter cube here, millimeter cube here. Then we change this one. Kilonewton, we change it to 1000 Newton. Okay? Change to the 10 to the 3. Then you cancel this. Understand? Okay? Then what you have is you just use 1325 divided by 180. Okay? So then the same thing, your moment normally is kilonewton meter. Why? Because you use the WL square over 8, and L is in meter, right? And W is kilonewton per meter. So that is why your units come out is going to be kilonewton meter, right? Correct? Because your moment, the way that you calculate your moment is equal to WL square over 8. And this W is, let's say, 15 kilonewton per meter, or in this case maybe 4.32 kilometer, and here you may have 12 meters square divided by 8, right? So you can see that the unit is going to be kilonewton meter, right? So you have to remember that my kilonewton meter, I have to convert it to Newton millimeter so that I can have the same units, right? So you convert it to 10 to the 6, and 10 to the 6, 10 to the 6 cancel out, okay? So I would suggest that your area, whatever you calculate, you should express it in 10 to the 3 millimeter square. Why? Because this, I put it in 10 to the 3, then I can cancel out the kilo. You understand what I'm saying? Okay? Same thing, this one, you put it into the 10 to the 6. I think your S1, you put it 1.8 times 10 to the 7, right? Correct? Correct. Huh? When you calculate your S, right? Or you put 18 times 10 to the 6. Some people put it 1.8 times 10 to the 7. But that is good. That is good because we are going to use the 10 to the 6 to cancel out with the kilonewton meter, right? But this one, you try to do it in area. You try to do it here 10 to the 3. You understand what I'm saying? Okay? You can put it 10 to the 5, but the thing is, if you put it 10 to the 3, then you can cancel this one out. Understand? Okay, so pay attention to the units. Okay? Pay attention to the units. Because for some reasons, you just take the number. You forgot about it. Not just you, a lot of people, even our local students, they just take the number and they don't even write the units. You should write the units. Then you can see. You see what I'm saying? Okay? I mean, it's just like this. Fair enough. You cannot just say L1 plus L2, L3 is equal to 3 plus 2 plus 3 without equalizing the units. Okay, fair enough. Okay, so this one, be careful. All right? So go back and rework it. Go back. I give you the answer. I give you the answer. So you just make sure that whether you can match my answer or not. Okay? All right? Then, because today mainly I want to talk to you about is the torsion. Okay? All right? Okay. For problem A, okay, at the midspan, the stress is this. This is a stress diagram, okay? This is F1, this is F2. F2, you should get negative 14.08 MPa, which is Newton per meter squared, okay? And F1, you should get negative 0.64. Okay? All right. And then part A is part A. Part A is, of course, at transfer. Okay? So at transfer, you need to do it, one for the midspan, the other one for the support. Support is easy. It's just uniform stress. And this F1 is F2. F1 is equal to negative 7.36. Okay? Alright, so this is the answer. Okay? See whether you can get this value or not. Okay? Then B is service load. At the midspan. You have active 13.38. Here F1 is equal to negative 16.38 MPa. That means compression. F2 is plus tension, 4.60 MPa. And then at the support, compression is negative 5.89. Okay, all right. Huh?
For the support, is minus Pi divided by A, right? Is stress divided by area.
This is at the transfer, right?
Yeah.
Yes.
For the at service.
And the service will be P effective.
Oh, yeah, okay.
P effective. Understand? So at the transfer, you use P initial, right? P initial, which is 1325. 1325 kilonewton. Okay. All right. And then you convert it to 1325 times 10 to the 3 Newton. Okay. All right. And then at service, you use P effective. Because P effective, because we use 20% losses, that means 80% left for the effective, right? So is 0.8. This one. Okay? Alright. Okay, alright. So I think the rest so area is correct, S correct. So these are all correct. Okay, here you see you put in the units.
Yeah.
But then when you come to here, you did not put in the units. Okay? Alright? Okay. Now remember in the final exam, in the test, the cross section is rectangular. Okay? In the final exam, it's not rectangular, it's funny shape. But I give you the area, you don't need to calculate. I give you the area, and also I give you the moment of inertia. I give you the Y1 and Y2. Okay? You just make sure that you calculate S1 and S2 correctly. Okay? Make sure that your S1, S2 is in the form of multiplied by 10 to the 6. Huh? Understand? Okay? If it is 2.7 times 10 to the 7, you change it to 27 times 10 to the 6. Yeah, I'm saying? So that we can cancel out the 10 to the 6, 10 to the 6. Okay, huh? Alright, huh? Okay. And also, the area, make sure the number is expressed and number times 10 to the 3. Okay? Because the kilonewton, kilo we express it 10 to the 3, then we can cancel out. One, yeah? Follow? Okay, huh? Alright, so this part, if you can do correct, then maybe you can get 16 or 17 marks out of 25. Understand? Okay. I think the part A is 7 marks, and then part B is 10 marks. Okay. Understand? Huh? Okay. All right. Huh? And okay, so now we want to talk about the torsion. Okay, torsion. Okay, the torsion. Okay, you guys, do you have the code for the part 2? DSA110 part 2. You didn't bring. During the final exam, the exam center will give you the code. But the thing is, you need to know where to find it. You see what I'm saying? Because but the torsion, I'll show you the part 2.